Find f of x if f s bar of p which is equal to p power n e power minus ap. So we need to find f of x. They have given Fourier sine transform of f of x. So from Fourier sine transform we are going to find f of x using inverse Fourier sine transform, right? We know the inverse Fourier sine transform of f s bar of p is given by f of x which is equal to root 2 divided by pi integral 0 to infinite f s bar of p sine px dp. That is equation number 1. Given f s bar of p which is equal to p power n e power minus ap, that is equation number 2. So using 2 in 1, f of x is equal to root 2 divided by pi integral 0 to infinite p power n e power minus ap sine px dp. That is equation number 3. We know that integral 0 to infinite e power minus ap sine px dp formula, right? In the formula we are having e power minus ax sine bx dx, right? Instead of px we are having p, right? Instead of b we are having x, right? So the formula is x by a square plus x square. The formula is b by a square plus b square, right? That we have replaced b by x, right? And a is a, and instead of x you are having p in the integral, right? So this can be written as x by, so factor of a square plus x square is a plus ix into a minus ix. That is equation number 4. Now we are going to use partial fraction to split x by a plus ix into a minus ix into two terms. So let x by a plus ix into a minus ix which is equal to a by a plus ix plus b by a minus ix. This is equation number 5. So taking LCM and equating left hand side and the right hand side, we will get x is equal to a into a minus ix in plus b into a plus ix. So this is equation number 6. So now we are going to find the constants a and b. For that, put a is equal to ix in equation number 6. So x is equal to a into, instead of a you are putting ix minus ix plus b into ix plus ix. So ix minus ix get cancel. So 2b ix, right? On the right hand side. So x and x get cancel. So you will get 1 equal to 2ib. So b is equal to 1 by 2i, right? B value is 1 by 2i. Similarly, we are going to find a instead of a, small a, we are going to put minus ix in equation number 6. So x is equal to a minus ix plus b into minus ix plus ix. Minus ix plus ix get cancel. So you will get minus 2aix, right? So x is equal to minus 2aix, x and x get cancel. 1 equal to minus 2ia, a is equal to minus 1 by 2i. So we are going to use the values of a and b in equation number 5. So 5 implies x by a plus ix into a minus ix, which is equal to, instead of a, minus 1 by 2i by a plus ix, instead of b, 1 by 2i plus 1 by 2i by a minus ix. 1 by 2i is common, take it outside. So first term minus 1 by a plus ix plus 1 by a minus ix. So denominator can be written as, so you are having 1 by a plus ix in the denominator. It can be written as a plus ix power minus 1. Similarly, the next term a minus ix power minus 1. So 1 by 2i a minus ix power minus 1 minus a plus ix power minus 1. This is equation number 7. So using these ideas in fourth equation. So integral 0 to infinite e power minus ap sine px dp, which is equal to x by a plus ix into a minus ix, which is equal to 1 by 2i into a minus ix power minus 1 minus a plus ix power minus 1. This is equation number 8. Now differentiate 8 with respect to a. So d by dA of integral 0 to infinite e power minus ap sin px dp, which is equal to d by dA of 1 by 2i a minus ix power minus 1 minus a plus ix power minus 1. So without loss in generality, we are taking differentiation inside the integration. So integral 0 to infinite, this is the differentiation is with respect to a. So with a there is only one term, that is e power minus ap. So d by dA of e power minus ap, then sin px dp, which is equal to 1 by 2i is constant. So first term d by dA of a minus ix power minus 1 minus d by dA of a plus ix power minus 1. So integral 0 to infinite derivative of e power minus ap with respect to a. So minus p e power minus ap sin px dp, which is equal to 1 by 2i differentiation of a minus ix with respect to a minus 1 into a minus ix power minus 2. So minus, similarly here minus 1 into a plus ix power minus 2. So integral 0 to infinite e power minus ap minus p can be written as minus 1 into p sin px dp, which is equal to 1 by 2i. Minus 1 is common, take it outside, into a minus ix power minus 2 minus a plus ix power minus 2. So taking minus 1 outside the integral, minus 1 into 0 to infinite integral e power minus ap p sin px dp, which is equal to 1 by 2i minus 1 into a minus ix power minus 2 minus a plus ix power minus 2. Again differentiate both sides with respect to a. So d by dA of minus 1 integral 0 to infinite e power minus ap sin px dp, which is equal to d by dA of 1 by 2i minus 1 into a minus ix power minus 2 minus a plus ix power minus 2. So again we are taking the differentiation inside the integral. So minus 1 integral 0 to infinite d by dA of e power minus ap p into sin px dp, which is equal to 1 by 2i minus 1 into d by dA of first term a minus ix power minus 2 minus second term d by dA of a plus ix power minus 2. So minus 1 power integral 0 to infinite e power minus ap into minus p, again differentiation, into p sin px dp, which is equal to 1 by 2i minus 1, again differentiation, minus 2 into a power minus ix power minus 3. We are using derivative of x power n into x power n minus 1. So minus 2 into a plus ix power minus 3. So minus 1 integral 0 to infinite e power minus ap, again minus p can be written as minus 1 into p sin px dp, which is equal to 1 by 2i. Minus 2 is common, take it outside, minus 1 into minus 2 into a minus ix power minus 3 minus a plus ix power minus 3. So minus 1 into minus 1 minus 1 square integral 0 to infinite e power minus ap p into p square sin px dp, which is equal to 1 by 2i minus 1, right? Minus 2 can be written as minus 1 into 2. So minus 1 again, 1 into 2, right? A minus ix power minus 3 minus a plus ix power minus 3. So minus 1 square integral 0 to infinite e power minus ap p square sin px dp, which is equal to 1 by 2i minus 1 square 1 into 2 a minus ix power minus 2 plus 1, 3 can be written as minus of 2 plus 1 minus a plus ix minus 2 plus 1. So we are going to form the general term. After n time differentiation, we will get minus 1 power n integral 0 to infinite e power minus ap p power n sin px dp. The previous term, compare the previous term. So for the second derivative, you are having minus 1 square integral 0 to infinite e power minus ap p square sin px dp for the second differentiation. So nth differentiation minus 1 power n, instead of 2 you replace n, integral 0 to infinite e power minus ap p power n sin px dp, that is left hand side. the right hand side 1 by 2i. For the second derivative you are having minus 1 square, right? So for the nth derivative minus 1 power n. For the second derivative you are having 1 into 2. For the nth derivative 1 into 2 into etc into n, right? So into a minus ix. For the second derivative a minus ix power minus 2 plus 1. So for the nth derivative a minus ix minus n plus 1. Similarly the second term minus a plus ix power minus n plus 1. So minus 1 power n integral 0 to infinite e power minus ap p power n sin px dp, which is equal to 1 by 2i minus 1 power n. 1 into 2 into up to n multiplication is nothing but n factorial. A minus ix minus n plus 1 minus a plus ix power minus n plus 1. So minus 1 power n minus 1 power n both side, right, get cancel. You can cancel in the previous step also. So when you are getting minus 1 square second for the second differentiation, right, that side also minus 1 square and right hand side also minus 1 square, you can get cancel that itself, right? So integral 0 to infinite e power minus ap p power n sin px dp, which is equal to 1 by 2i n factorial a minus ix power minus n plus 1 minus a plus ix power minus n plus 1. That is equation number 9. So we are going to consider the term a minus ix power minus n plus 1 minus a plus ix power minus n plus 1. So we are putting a is equal to r cos theta and x is equal to r sin theta. So a minus ix power minus n plus 1 minus a plus ix power minus n plus 1 becomes r cos theta minus I r sin theta power minus n plus 1 minus r plus cos theta plus I r sin theta power minus n plus 1. R is common, take it outside. R power minus n plus 1 into cos theta minus I sin theta power minus n plus 1 minus cos theta plus I sin theta power minus n plus 1. So r power minus n plus 1 into cos theta minus I sin theta can be written as e power minus I theta whole power minus n plus 1 minus e power I theta power minus n plus 1. Because we know cos theta plus or minus I sin theta is equal to e power plus or minus I theta, which is equal to r power minus n plus 1 e power I n theta plus 1 minus e power minus I n plus 1 theta. So we know e power I theta minus e power minus I theta, which is equal to 2i sin theta. We are going to use this. Therefore a minus I x whole power minus n plus 1 minus a plus I x power minus n plus 1, which is equal to r power minus n plus 1 2i sin n plus 1 theta. That is equation number 10. Since a is equal to r cos theta and x is equal to r sin theta, squaring and adding a square plus x square equal to r square cos square theta plus r square sin square theta. R square is common, take it outside. R square into cos square theta plus sin square theta, that value is 1, therefore r square. Therefore r is equal to square root of a square plus x square, right? R a square plus x square power 1 by 2. That is equation number 11. Now x by a is equal to r sin theta by r cos theta. R get cancelled. Sin theta by cos theta equal to tan theta. Therefore theta is equal to tan inverse of x by a. That is equation number 12. So using 11 and 12 in 10, we will get a minus ix power minus n plus 1 minus a plus ix power minus n plus 1 equal to, instead of r we are putting a square plus x square power 1 by 2 whole power minus n plus 1 and 2i sin theta n plus 1 into, instead of theta, tan inverse of x by a. That is equation number 13. Using 13 in 9, we will get integral 0 to infinite e power minus ap p power n sin px dp, which is equal to 1 by 2i n factorial a minus ix power minus n plus 1 minus a plus ix power minus n plus 1 equal to 1 by 2i n factorial a square plus x square power n by 1 by 2 power minus n plus 1 2i sin n plus 1 tan inverse of x by a. So taking 2i outside, 2i by 2i n factorial. So multiplying the powers of a square plus x square, you will get a square plus x square minus n plus 1 into 1 by 2, that is minus n plus 1 by 2 sin n plus 1 tan inverse of x by a. 2i get cancelled, n factorial a square plus x square power minus n plus 1 by 2 sin n plus 1 tan inverse of x by a. That is equation number 14. From 3 and 14, f of x is equal to root 2 pi by pi integral 0 to infinite p power n e power minus ap sin px dp, which is equal to root 2 divided by pi n factorial. We are substituting the value from 14, equation number 14, into a square plus x square power minus n plus 1 by 2 sin n plus 1 tan inverse of x by a. Therefore, x of x is equal to root 2 divided by pi n factorial by, so a square plus x square whole power minus n plus 1 by 2 can be written as 1 by a square plus x square whole power n plus 1 by 2. So n factorial by a square plus x square power n plus 1 by 2 sin n plus 1 tan inverse of x by a. Thanks.